Question number 4. 0.5 molar aqueous solution of a weak acid HX is 20% ionized. If Kf for water is 1.86 Kelvin kg per mole, the lowering in freezing point of a solution will be option A 0.56 Kelvin, option B 1.12 Kelvin, option C minus 0.56 Kelvin, and option D minus 1.12 Kelvin. Right. So therefore, let's consider a weak acid HX. Now, a weak acid HX undergoes dissociation as H plus of X minus, right? So for any weak acid that we would consider, for a weak acid, let's take 1 minus of alpha as a dissociation. So this is going to give me as alpha and alpha, right? So therefore, we would say that alpha is 20%. Therefore, if we do consider the calculation of Van Hoff's factor I, that is equal to 1 minus of alpha plus alpha, these things, right? So therefore, I is equal to 1 minus alpha plus alpha. So these particular alphas will get cancelled. So I is equal to, as what we are going to get is 1 plus of alpha, right? So therefore, if we do consider alpha, okay, as 20%, for 1 liter, the value of alpha would be as 0.2%. Okay, as it is 20%, the value of alpha will be for 1 liter as 0.2. Therefore, we would have the answer as over here as I is equal to 1 plus 0.2 because of this particular terminology. So it will become as 1.2. Now, final point, that is delta TF. Delta TF is equal to I into KF into molarity. Now, let's check one by one. So delta TF is equal to I value is 1.2 into KF. Okay, so KF for water is 1.86 as what they have already given us into, okay, so what we have is a molar as 0.5, so 0.5. So this particular thing, once we calculate 1.2 multiplied by 1.86 into its half, that is 0.5, this particular value of TF would give rise to 1.12 Kelvin. So therefore, our answer is B. Thank you.